Hello, everybody. Good morning, good afternoon. Welcome to this webinar session on X9 products. Today, we have our speakers, Dr. Massimo Calabrese, that is the director of the breast diagnostic department in Policlinico San Martino in Genoa. Together with him, we will have other two breast radiologists that are Dr. Garlaschi and Dr. Recinito, who will show us some clinical cases and the benefit of our BreastNav technology. So if you have any question, you can write the question directly in the chat. We will have a dedicated session at the end of the presentation. Now I leave the word to Dr. Calabrese to introduce you the workflow of the center before going directly on the BreastNav details. Enjoy this webinar.
Thanks, Martina, for your presentation. Good afternoon. My name is Massimo Calabrese. I'm the director of the breast diagnostic department of San Martino Polyclinic Hospital in Genoa. And now I'm the president of a breast section in Italian Society of Diagnostic and Interventional Radiology, CIRM. Today, I would like to introduce you our center and our daily workflow. In our department, we visit about 80 patients every day, and we perform a mammogram, tomosynthesis, breast ultrasound, breast MRI, ultrasound guided and MRI guided biopsy, vacuum assisted breast biopsy, and contrast media digital mammography. In our group, we are 7 breast radiologists, and the number of breast imaging examinations that we perform every year is more or less 20,000. Innovation today is fundamental in radiology, and the research and development of new technologies keeps opening new possibilities in diagnostic and therapeutic fields. We are collaborating with Esaote to develop important research protocols aimed to improve the diagnosis and the follow-up of breast cancer. In particular, for the breast cancer care, a multidisciplinarity and multimodality approach is becoming increasingly important, with the aim to be prompt in initiating the appropriate treatment and decrease mortality. In this webinar, my colleagues Dr. Garlaschi and Dr. Recinito will illustrate the clinical value of BreastNav technology, a very promising technique to follow up breast lesion, and BreastNav MRI, which allow to perform the fusion imaging between the ultrasound and MRI. Thank you for your attention. I leave now the word to Dr. Giuseppe Recinito.
Dear colleagues, good afternoon and welcome to this webinar. Please allow me to thank Dr. Calabrese and Esaote for invitation. And we will talk about BreastNav ultrasound technique. It is a new and very interesting, promising ultrasound breast imaging navigation technique based on a model adaptive artificial intelligence algorithm that reproduces a virtual 3D shape breast model, and in this way allow us to have one-to-one breast morphology patient correlation during our real-time ultrasound study. The system also stores all data in the ultrasound archive on PACS for post-processing analysis and review, and allow us to print pictures with target, reference, and probe spatial position, and also our reports with BI-RADS classification. In the same study, there's the possibility to achieve other ultrasound features of the target lesion in a multimodality breast ultrasound approach using Doppler microvessel and, as we will see, microenhancement and elastosonography evaluation. In that way, BreastNav represents a very important and effective tool to quickly re-identify our breast target on BreastNav ultrasound evaluation, and should be a very accurate tool for localize and to follow up ultrasound breast lesions. We will explore about imaging technique and acquisition, feasibility of procedure, possible limitations, advantages, in particular on speed up localization and as basis of BreastNav ultrasound MRI fusion, and how this tool can help us in clinical workflow application for both patients and operators. BreastNav is based on algorithm registration system implemented on the MyLab X9 exhaustive ultrasound device, an electromagnetic tracking system that consists in a transmitter near body position near the body of the patient, and a receiver antenna mounted on the linear probe, can map the probe sweeps in different position and inclination during our ultrasound study. In that way, virtual model is readapted on the basis of the patient breast shape modeling and allow us to localize breast covered area and detect, store, and re-identify our breast target. Before ultrasound study, we need to perform a very quick and easy registration phase. In 2 sweeps, one horizontal, one vertical, with as less as possible probe pressure, as you can see on the video. The system traces the profile of the reference patient's breast, in which P1 is needle, P2 and P3 are medial and lateral margins of breast, and P4 and P5 are inframammary fold and subclavian line. And the model automatically adapts breast shape to provide 1-to-1 correlation during our ultrasound study. If a breast lesion is identified, we put a target on the lesion that will be our virtual target and save it and the probe spatial position within patient's ultrasound study. We also have track visual feedback of the breast cord quadrant. So during ultrasound follow-up, BreastNav technology will show us the target previously saved, ultrasound reference images, and corresponding breast 2D and 3D virtual model probe position to quick identify known lesion. Also, there are on screen traffic light indicators that can help us to identify the exact transducer spatial position to reach the achieved target. But we are radiologists, and as radiologists, we love images, so let me show some clinical cases. This is a case of a very young woman with a short follow-up of benign but not definitive diagnosis of 8mm nodule, in which breast navigation was very helpful to refine the target that was quite changed our percutaneous biopsy procedures, as you can see in this video. While in this other patient with a significantly increased nodule in left breast at 6 months follow-up, BreastNav was very useful to speed up detection in the successive follow-up of this hyperplastic fibroadenoma. Another very interesting application of BreastNav technique is the identification of previously known malignant lesion for accurate preoperative needle localization, in particular in very small apoechoic malignant lesion inside a very fatty tissue composition breast. So the benefits of this new technology is speed up the re-identification of breast target and simplify our clinical ultrasound workflow, in particular to follow up 9 lesions into accurate preoperative localized non-palpable malignant nodules. And the possible limitations of this technique is the obvious learning curve. the breast type, tissue composition, and lesion position related to the breast morphology of the patient, and the small sample size of patient in all preliminary studies. But as usually, medical technology will help us because big data improve machine learning procedure in order to increase algorithm accuracy and diagnostics confidence. The clinical advantage of BreastNav is that it's a very fast, easy, and reproducible procedure, effective tool for lesion detection, visualize covered breast area, and also probe position and inclination in previous saved ultrasound study, and complete tool. Because inside BreastNav environment, there's the possibility to enable other advanced ultrasound technologies such as microvessel, microenhancement, and elastosonography evaluation. Lastly, BreastNav represents the technological basis of BreastNav supine ultrasound and prone MRI fusion imaging technique, as we will hear later from Dr. Garlowski. Thank you for your kind attention.
Good morning. Thanks to Dr. Recinito and Esaote. The subject of this report is the fusion prone MR and the supine ultrasound. Why? Why was it necessary to combine the information between MR and ultrasound? What are the possible applications of this technique? When should it be used? Any answer? Possible answer are second look ultrasound for unexpected lesion to MR, patients with non-biopsiable MR lesion, patients with difficulty in keeping the prone position for a long time, less invasivity of sample under ultrasound guide, and reduction of waiting times. Because it is necessary to find a valid alternative to MR biopsy, poorly present, not always precise, expensive, and often limited by this physical confirmation of the patient or the position of the findings, too deep or too superficial. It's not a new technique. In fact, several studies already have obtained a fusion between MR and ultrasound, but with a complex expedient and with even with the necessity to perform an implementation to the standard protocol in prone position with a new sequence in a supine position, or need a second new supine MR with no dedicated coil. This procedure is often complex with a result not always diagnostic. As you can see in this example, with on left a big lesion in right breast, and after in the right image the same patient and the same lesion not diagnostical. It's not possible to see the same lesion. Also, the system of fusion supine MR with supine ultrasound require the use of the skin landmark with vitamin E tablet, visible MR, as essential anatomical reference for the purpose of coregistration, positioned in the paraareolar area at hours 3, 2, and 12. As you can see in the anatomical imaging, after the same patient in the prone MR and supine MR. The new system, the new fusion system with prone MR and supine ultrasound, with algorithmic co-registration system implemented on MyLab 9X9 ultrasound system by Esote, requires the use of electromagnetic receiver and linear probe with high frequency with reusable check and bracket with a sensor mounted. And the lower image, we can see the interface of this system. There is a registration procedure prone MR from PACS system, and ultrasound supine imaging use a 3D adjustable breast model for calculate correspondence and deformation based on points. The first step is to load the MR sequence directly from PACS or external support on the ultrasound system. If one or more suspicious lesions are identified, there is the possibility to position a virtual target on the MR. First of all, for registration phase based on 5 fixed anatomical points on the MR: nipple, medial and lateral margin of breast, inframammary fold, parasternal line. The registration phase based on 2 sweeps, horizontal and vertical, with ultrasound probe directly on breast without any pressure. There is no need to use a vitamin E tablet, which also caused a deformation of breast profile. Remember, this is a very important point. Once the 2 procedures have been co-registered, the focuses of interest can be inserted in the same area of double full contrast, and the reference is automatically projected in the same location of ultrasound. Currently, the discrepancy gap is estimated at around 412 millimeters. But today, the goal is not to achieve a perfect overlap, but to have a reliable guide. As you can see in this image, with the interface of fusion system, we can find a little lesion nearly the circle corresponding at the MR. Well, resume the benefit. The procedure allows you to effectively perform a second look ultrasound. It's a valid alternative approach to breast biopsy, MR, useful for the confirmation of disease poorly accessible with conventional diagnostics. The limits are margin of error of the algorithm, difficulty to co-registering hypertrophic breasts. We offer you a interesting clinical case meet in our center, which demonstrate the effectiveness of this technique. We have a 43-year-old woman with infiltrating lobular carcinoma on the lower right quadrant. Staging MR show more than one focal pathology. As you can see in the upper and the lower right imaging. But fortunately, with the interface and the fusion system, we can find both lesion in ultrasound. This is the lesion, and this is the area, the circle of double full contrast area on the MR, and this is the second lesion on right breast. Well, after biopsy, these lesions are confirmed to be another lesion in another localization of lobular carcinoma. Future implementation. Further refine the remodeling and co-registration algorithm in order implementing the case study to minimize the margin of error. algorithm optimization to make it less operator dependent. Thanks for attention.
Okay, thank you all for joining this session. We hope that you enjoy the presentation, and now we are here live to answer all your questions. So please, if you want to submit any question, simply use the chat box, and we are here to answer you. Okay, I cannot see any questions coming yet, so let's wait a couple of minutes.
So it was all too clear or too thoughtful presentation.
Okay, something has arrived. So we have the first question from Georgia. So, which is the tech accuracy of registration at MRI and US?
Okay, I can answer this because it's more a technical question. So, by the way, let me just introduce myself to let you understand who I am. I am the, let me say, product specialist from Esaote, following the project together with this center. So the accuracy depends, of course, on the morphology and the different shape of the breast that are under examination. So we can go up to 0.2 up to 9 millimeters, depending on the shape of the breast and on the localization of the particular lesion.
So if I can to support your answer, in clinical practice, the real goal is not to find the real target in the same position of the MR examination, but allow us to cover the area or quadrant in which the lesion is positioned. So the misalignment in our experience also in preliminary studies and the Esaote experience with other centers was from 0 to if we know where the area of the lesion is, where we have to study the area of the lesion, area of the breast, we have a very effective tool to cover that quadrant of the breast and to find that lesion also.
Okay, thanks. We have another questions coming. So do we, just a moment that it moved down. So do you understand that if you come 5 millimeters close to the correct position, then you can find it only using ultrasound alone?
Yes, yes. Let me say that the goal here is precisely this. So you can use the target that you put on the MRI, where you can see very well the lesion, and then the target is reproduced in real time in the ultrasound. So you know precisely the localization of the target that can help you to localize the same lesion in the real-time ultrasound.
Okay, thanks, Marty. And there's another question now. Thank you for, first of all, thank you for the great presentation about BreastNav. I have a question about which roles of BreastNav technology is search and missing nodules in US? Which BreastNav can help for this case to localize and follow up? I hope to have been clear.
Yeah, I can answer this interesting question, and thank you for the question, because in clinical routine, BreastNav can allow us to find again in follow-up that lesion. And the time that we spend in acquisition or registration phase is less than the time that we save follow-up with that patient. So if you miss at first step your lesion, you can't use after BreastNav. But if you find it, you can use very easily.
Okay, thank you. So maybe Marty, this one for you. Is this a prototype or available as a commercial product?
It is already available. As we said at the beginning of this presentation, it is a technology that is commercially available, and it's on our top-end product of Esaote, that is MyLab X9 and MyLab 9.
Okay, thanks. Last one coming. So on the end of the day, the additional effort for fusion is costing time or saves time after all because you find faster the target?
So maybe Giuseppe, you want to answer from a clinical point of view, then I can integrate.
If I correctly understand, the colleague asks if there's a costing time or save time procedure. Finally, if you after layman cure, this procedure will save our time. Also, save the psychological effort of patients, because our second look ultrasound was more effective, otherwise was not definitive. So in that way, we can use WebMR. In most part of cases, we can use BreastNav to find the lesion and get the ultrasound guided biopsy procedure more comfortable for patients and easy for us, and less more cost effective for system.
Thank you, and let me integrate also that today the technology is based on artificial intelligence. So we have this model, virtual model, that is readapted on the basis of patient breast, and this can help to, let me say, manage the deformation between the prone and the supine position. In this first step, there are some manual steps that the radiologists need to perform in order to give the input to the algorithm, but our aim is to automate this as much as possible in order to improve also the fastness and the easy to use of the algorithm.
Okay, thanks. So we have no other questions coming as of now, so let's wait a couple of minutes and then maybe we can eventually close.
Okay.
Okay, I cannot see any other question coming. I can see a raised hand from Nat Ningue. I don't know if I've pronounced it in the right way, but if you want to make a question, you can write in the chat. Oh, it's coming. So it's related to a question that was made before. So first of all, he's thanking for the answer, and then he's asking for another one. So you said that it's easy to use BreastNav or Fusion to localize and follow up. So do you have any clinical case can be shared with me, maybe also after the presentation?
Sure, we have an really happy to share with you. And let's just do a clinical consideration. We don't have any other questions. Another clinical consideration is that technology, generically speaking, will help us anyway, because with the limits of patients' breast tissue composition, breast prone to supine, Esaote allow us to give markers on the skin. and either to define MR study, another study for to perform just one MR in prone position, one ultrasound supine position, to do our improving with result. So we hope that algorithm will improve the accuracy to, let's say, to have a mesalink as possible. Another thing that we have developed with is all this pressure of the skin during in the pre-registration phase. This is also operator dependent, but it's just the technical procedure operator dependent. For other things, localization, the ultrasound, medical, is fundamental.
Giuseppe, we cannot hear you very well. If you can just come closer to the microphone, because we lost you for a while.
Oh. All my words are just
No, I think you can just recap.
Technical consideration, which I spent just a few seconds to say that the collaboration with ESAOT and with other technology industries is help for us to improve also the technical procedure, such as the sweeping for the registration phase. We will improve the movements and the pressure on the skin, and we will improve the technical routine acquisition. But the final clinical goal is also to add the clinical experience of the operator for sure arise from also technical advantages. That's it.
Okay, thank you.
Okay, there is one last one. So, and one thing about in the case you have a group of nodules, in your experience, which way of biopsy you should use? We have many cases of this, and interesting if we use the BreastNav.
If I correctly understand, the colleague asked about which biopsy you choose.
Exactly, in case of if you have a group of nodules.
Yeah, if BreastNav was successful conducted and the nodule was detected, the first approach was with true cut for histologic evaluation, and the true cut was from 14 to 18 bush. Also, we use the ultrasound guide for VAB evaluation, but this is a second step if the true cut was not definitive.
And let me add that in this case, the technology can help, because with BreastNav there is the possibility to position different targets. So if you have multiple nodules, you can position one target on one nodule and another target on another one, and the system suggests how to, let me say, to find back and to follow up the specific different nodules.
Okay, thank you. Let's wait a couple of minutes and then we can close the session if there are no questions coming.
Yes, sir.
Okay, I can't see any other question coming. So Thank you for joining, and I'll leave the floor to Dr. Giuseppe Recinito and Martina to conclude the session. And do not forget to follow all our next appointments on Esaote website. Thank you.
Thank you, Valentina. I would like to thank you, Dr. Recinito, Dr. Calabrese, and Dr. Garlaschi for their availability. And I would like to inform you that this webinar will be available on our Esaote website. Thank you all for joining.
Thanks to everybody.
We can close here. Thank you. Bye.